First capacitor is removed, that is 25 pf, as you can see, and I remove this capacitor here. This is the coil across that. This 20 pf supposed to be over there. So 24.7, so it is 25 pf. I'm gonna put there 20 pf. Let me measure that. Those are the 20 pf. So before I put 20s over there, I just want to remove the inductor and measure this capacitor value as well as this inductor value, so that I can calculate it for my future modification. Hopefully everything would be all right after I remove this all. I don't want to ruin this front end. So I wanted to remove those capacitor marked like 22 pf and 16 pf across the oscillator inductor, and that is the inductor, and those are the capacitor and the tin foil. So I need to remove that one. That need heavy duty iron. So yeah, 900 watt iron will do that, I guess. Let me check the values right now. The red one is 22, 22, the 22, it matches, and this one 10, but here it is 16. PF. Yeah, definitely that is 10 PF, but here it is 16 PF mentioned beside 22 PF. C27. I can measure that one as well, and I can put the value over there. It is not mentioned what is the value of T05. So now only thing left with this gang is this T03 inductor, this one. So I'm thinking to remove this one as well, and we'll measure the inductance. Let me remove this one carefully. Proton. First, I will measure the capacitance. So minimum capacitance is 1.2 pF. So it is almost like a 15 pF capacitor. So let me put it there. This value, here T05. (15 pF) max, 1 to 15 pF actually. Like 40 nanohenry. Check it with my another inductance meter. Showing 70 nanohenry. Wow, huge difference. 3, almost 70 nanohenry. So I am measuring the tuning condenser. This one. When fully closed, it's showing like 60 pF. 60 pF. When fully open, then it is 29 pF. So it would be like probably 30 to 60 pF for the oscillatory section. It's maybe like 30 to 60 pF. (28 pF). For the lower value 27.9, that's mean 28, and the highest one is 58.9, 59 pF. So this one is quite perfect. 30 to 60 pF is the right value, I guess. 60 pf. $28.45. So I'm taking 30 to 60. That's it. Now I will calculate my series capacitance to get my desired frequency, that is 76.8 to 97.8 megahertz. So here is my modification for the FM tracking oscillator section. Oscillatory section. Previously it was C27 was 10 pf and C28 was 22 pf, and I measured the inductance, that was like 67 nanohenry, and the frequency range was like 76 to 90 megahertz for the Japanese band. So here is my modification of the FM tracking oscillatory section. The values are like here C27 was 10 pf and C28 was 22 pf, and I measured the inductance, that was like 67 nanohenry, and the capacitance range was 30 to 60 pf. So I recalculated the range to get my desired bandwidth, that is 87.5 to 108.5. So I subtracted 10.7. So the lower end is 76.8 and upper end is 97.8. And for the tuning band, the ratio would be like 1.62. So I have added 18 pf, and the ratio is matching perfectly, 1.62 with 55 nanohenry. I can achieve the frequency range. And here you can see I have changed the inductor value, that is 55 or something, little bit of more than 55. I have to adjust that, and I put this trimmer capacitor, that is here 15 pf, and total capacitance would be like 18 pf. So I have removed 22 and 16 from there. I have just put 15 pf across it. As you can see, this is the 15 pf here, 15 pf. Now the frequency, you can see, that is the upper band, 97 98 megahertz upper band, and let's go to the lower band. Seventy-six point 76.8 is the lower band. So it is perfectly all right. I need to modify it a little. I mean adjust little bit with some insulator screwdriver, like that. That inductor will change the frequency, as well as this capacitor, the trimmer capacitor, also change the frequency. So I'm very happy that I can achieve the range. So now thing is like only I have to change this capacitor as it's recommended, like 20 pf instead of 25. Hopefully that will work okay. Now I have to put this to my SANSUI TV919 and we'll see the bandwidth and how it is working. So before I do that, I just want to measure this inductance and this capacitance range. The oscillator resection I measured like 30 to 60 pf. Here it is, and I don't know this value because these are not like same pin number. Look at that. That is more in like 1 to 6 plate over there, and here it is 4 plate. So this is the less capacitance than that. So I need to measure that one as well. So I removed those 25 from here and here, and from there you can see these are 25 pf. They are supposed to be 20 pf for the international variation, and I need to measure the capacitance for this one. So I need to remove this inductor. So I'm removing this inductor right now. This is already desoldered from the ground. I'm not moving the coil, just want to measure it. So this gang is completely isolated now. I can measure it with my capacitance meter, and I will also measure the inductor. 4 turns. I think that is 6 mm of diameter. The inductor value is showing like 75 nanohenry. So I think it's reading 76. So I verified each time it's giving me like 76, 77, sometime 80. So I believe this inductor is like 80 nanohenry, not 75. I put those capacitor 25 pf from there. It is showing exactly 25.33 pf. Now let me check the tuning condenser. So I am measuring the tuning condenser right now. It is showing 30 pf, and let me tune it across it now. .828281. I think that is 10 to 30 pf. 11.47, the minimum capacitance, and the maximum is 30. This meter showing it 100 nanohenry, 99.9 nanohenry. So now we'll put those 20 pf. 20 pf is enough in this place, as it says 20 pf instead of those 25 that I removed from there. this inductor as well, then it will be complete. So I have completed my front end modification. I have put those 20 PF 1, 2 and 3. Previously there was like 25 PF. I have kept them and I put 20 PF according to the schematic. Hopefully that will track well. I have measured the inductor, that is 80 nanohenry, not 70, and the capacitance for the tuning range is 10 to 30 PF. I have also measured this inductance and the tuning range of this oscillator, that was 30 to 60 PF, and I have calculated the value of capacitor to achieve my desired frequency, that is 87.5 to 108.5 megahertz, as well as 88 to 108 megahertz. That is the same thing. I have taken a little bit of offset, so that would be okay. So I had to put like 55 nanohenry with 18 PF or 52 nanohenry with 88 to 108 range. So I have already tested with that inductor. As you can see, that was measured exactly like 56 or something. I have measured it with my inductance meter, and I have put 15 PF over there. So with trimmer on that one, it will cover the 18 PF. So now what I'll do is I will put this on the tuner, and we'll check the frequency reading, actual frequency reading on the tuner. Let me do that. Everything is connected. Now I'm going to give the power. Moment of truth, if display comes out with proper frequency. Yes, 87.5 megahertz. Let me tune it. So I'm trying to align my front end with my tiny SA. Sorry for the glare. And I have to move those coil to get the peak. Alignment is almost complete. You can see I have to tweak those inductors to get it properly aligned. Only with the capacitor it was not possible to align it properly, so I have to tweak those inductors. So now let me connect it with my antenna, and hopefully it will pick up some channels. I have aligned the front end, but still it is not the best. On 3.7 registration. Little bit of signal. Anyway, we'll again test it with my another front end and we'll see. I don't know why, but with this front end it is just picking up only one channel, the strongest one, and the signal meter is below 2, but the previous one, original with the TU919, that was above 2, like 2.557 or something. That's mean my front end was better, that one was better. With this tuner, scale is almost touching the level 3 signal meter, level 3 of the signal meter.